Hi everyone, this video is called Linear Equations in X, and jumping off of what we did just yesterday when we talked about expressions. Now these are equations, and of course equations make themselves equations by having an equal sign there. So this is the difference. And what mathematicians do is take equations and solve them for x. But we're not even going to go that far today. We're going to leave solving for another day. We're simply going to take some equations and determine what value of x makes the equation true. Alright, and we're going to do this by providing you with some examples, or some possibilities, I should say, not examples, some possibilities of what may make the equation true. Alright, so here's number one. It says here's an example of a linear equation, and from yesterday we know it's a linear equation because the x has an exponent of 1 on it. Alright, if it had an exponent that's other than 1, it would not be a linear equation. It would be some other type of equation. Alright, so our job is to find the number for x that makes the equation true. Now linear equations are pretty straightforward. Alright, you're just going to take this number here. We're going to say, is it true when x equals 2? Well, in order to determine that, you simply plug in 2 every place you see an x. Alright, so I'm going to take this equation and I'm going to write 15, and I'm going to use parentheses here. I'm not going to use a little dot. I think that makes it a little more confusing. I'm going to put in parentheses and just plug in a 2 for the x, and now I'm simply going to do the math on each side of the equation. Alright, remember, we usually, and I'm going to put this in red here, we usually look at sides of the equation as a line going right through that equal sign. Alright, so this would be one side of the equation, this would be the left side, and this would be the right side of the equation. Alright, so I'm going to switch back to blue here, and I'm simply going to do all the math that I can on each side of the equation. Alright, well the right side, that's pretty easy. That's 49. Alright, there's no math to do over there. And the left side, you notice we've gotten rid of all the variables, so there's no algebra to do. It's just simply do the math, and I have to follow my order of operations. So order of operations says do the multiplication first. So this 4 is just going to come down, and 15 times 2 gives me 30. And then I'm going to bring it down again. I'm going to do the next step. 4 plus 3, or 4 plus 30 is 34. And bring down my 49. And I've done all the math I can on both sides, so I have to ask myself, is that true? Okay, and no, 34 is not equal to 49, so I'm going to put a slash through it, and that tells me that no, x equals 2 is not a solution to the equation. It does not make the equation true. Alright, so let's try the other one. I'm going to do the same thing. I'm going to take the original equation. I'll put the original one down here because it's kind of separated from the other one here, and I'm going to plug in a 3 where I see the x. I don't need that on the outside. Let's take that away from there. Alright, let's put the plus 15, and I'm going to put a 3 in where I see the x. And again, I've got two sides to the equation. I can draw that in if you'd like me to. I could put in a little bar here and put in that line just to separate those two. Okay, and I'm going to do the math over here. 15 times 3 is 45, and I'm going to bring down my 49 over here, and then 45 and 4 is 49. So yes, this one came up true. 49 equals 49. Alright, and when it comes up true, well, that means that this is a solution, or it makes the equation true. So yes, x equals 3 makes the equation true. Alright, and that's really it. We're not solving anything, we're not doing any algebra. We're just simply plugging in a possible number and see if it works. Alright, so let's switch over to the next one. Here's another linear equation. Again, I know it's a linear equation because the variable has 1s as the exponent. Alright, so let's test these two and see if it works. First, let's try x equals 5. So every place I see an x, I'm going to plug in a 5. Alright, plug in a 5 right there. And now, really, we've taken away all of the variables. We've taken away any kind of algebra I would have to do because there's no variables left. Alright, so simply do the math over here. 8 times 5 is 40. And if I do the next step, 40 minus 19 gives me 21. Alright, and I'm going to bring down the other side. And I'm going to do, now be careful of your negatives here. This is negative 7 times 5, so I'm going to bring down this negative 4. And negative times a positive is a negative 35. Alright, and negative 34 minus 35, well, that's going to give me a negative 39. So I'm going to draw a line through my equal sign and say, no, they are not equal. Alright, so no, this does not make this true. Alright, well, let's try the other one. I'm going to rewrite the equation here. And I'm going to plug in a 1 everywhere I see an x. Oh, that was good. I plugged in an x for the x. Alright, I'm going to plug in a 1 every place I see an x. Okay, just like that. Alright, and for the last time, I'm not going to do this every time. I put in this line to separate my two. If you have to do that, that's fine. That's cool. Alright, you're still learning, so that's good. So 8 times 1 is 8. And let's see if I can do the other side at the same time here. Negative 4 comes down, and negative times positive gives me negative 7. Alright, now I'm going to go back over to this left side here and say 8 minus 19. Well, that gives me negative 11. And negative 4 minus 7, well, that gives me a negative 11 as well. So those are definitely equal. So I'm going to put up here, yes, that makes that true. Okay, so pretty straightforward there. Let's turn this one off and let's put on number 3. Okay, what's that? No? Okay, let's turn that off. And let's go to exercise number 3 here. And it says, is 5/4 a solution to the equation such and such? Alright, now we got to be big boys and girls now. A lot of people, they get scared when they see fractions, but we can do fractions. We've been doing them since like 4th or 5th grade. Alright, so I'm going to put in a 5/4 every place I see an x. And I'm going to use my parentheses. I just think it's neater, you know, when you put in a set of parentheses there instead of having that dot there. That would be fine, but I just think it's neater when you do that. Alright? So let's take a minute and do the left side of the equation. Alright? I could do two different things. I could distribute the 3, or I can try to get a common denominator. If I'm going to add 5/4 and 9, I need a common denominator. Alright, so I'm going to do that. I'm going to go off to the side and I'm going to write 9 as a denominator of 4. So really it starts out as 9 over 1. Alright, and I need a common denominator. It's going to be 4. So I'm going to turn that into, let's see, multiply both top and bottom, the denominator and the numerator, by 4. That's going to be 36 over 4. Okay, and if I add those together, I get 41 over 4. So this is going to turn into 41 over 4. And let's just finish the left side before we go any further. When I multiply a number times a fraction, I really just turn that number, that regular number, into a fraction. So what is 3 times 41? That's going to be 123 over 4. So I want to see if this right side is going to become 123 over 4. So let's try to do this, alright? Let's see, first I do my multiplication. So 4 times 5/4, well, that's really 4 over 1 times 5/4, and I can cancel on the diagonal. So this really turns into 5. Okay, I'm going to bring down my minus 7. And same thing here. This really turns into 7 over 1. So I can't cancel here. 7 times 5 is 35 over 4. Alright, and the same thing. I need a common denominator between these. Before I do that, though, I can take 5 minus 7, and I can get negative 2. And I'll just bring down the 35 over 4. And I'm going to go over to the right side and get my common denominator here. Again, the common denominator is going to be 4. Alright? And so to turn this negative 2 over 1, I'm going to multiply the top and bottom by 4. So I get negative 8 over 4. Alright, and when I add those, negative 8 plus a 35, that is going to be positive 27 over 4. Okay, so I'm going to copy this 123 over 4 down and get 27 over 4 over here. And obviously those two are not equal. Alright, so my answer would be no. That is not a solution to the equation. And here is exercise 4, and we're doing the exact same thing. We want to know if 6 is a solution to this equation. So I've got 3 different places where I have an x, so I'm going to plug a 6 into each one of those x's. I take the x out and plug the 6 in. Alright, and now I just simply do the math on each side. Follow my order of operations. And negative 2 times 6 is negative 12. And bring down the 11. Now watch this one right here. Notice what I say. I say to myself, negative 5 times positive 6. Whatever I get as my answer, that's what I write. I get an answer of negative 30. It's that easy. Okay. A lot of people confuse that. They think, oh, I have to bring down this minus sign because when I'm done I get a negative 30, and they actually write minus a negative 30. No, 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 no. Make it easy on yourself. Just simply take the symbol with the number, include it in your operation, and whatever you get as an answer, that's what you write. Makes it so much easier. Alright? And let's see, negative 6 times 6 is negative 36. Alright? And we continue to do the math here. Negative 12 plus 11, that's going to give me a negative 1. And 5 minus 36, that is a negative 31. And I've got some subtraction to do over here. Negative 1 minus 30 is negative 31. And that's equal to negative 31. So this one came up equal. That is definitely true. So, yes, this is a solution to the equation. Alright, so very easy, very straightforward. Just plug them in, do the math. Hopefully that went well for you. So thanks for watching. Have a good night, and we'll see you tomorrow.